The next presenter is Tiwari, and Kumud is coming from Banaras University. He is going to be talking on the role of transcription factors TTF1 in UV-mediated damage repair. 8 minutes plus 2 minutes.
Good afternoon everyone. My name is Tiwari, working under Dr. School of Biotechnology, Banaras University. My today's topic is role of transcription factor TTF1 in UV-mediated DNA damage repair. Now TTF1, that is transcription termination factor 1. It is an essential mammalian transcription factor and it also known as RNA polymerase 1 termination factor. The gene which encodes is present on the long arm of chromosome 9. TTF1 play a crucial role in different cellular functions like RNA transcription initiation, termination, chromatin remodeling, DNA for blockage. Besides of all these functions, there is always a scope for the novel finding of the novel interactors or the novel functions. So that I will talk in this discussion. So TTF1 become more important when its discovery that its play role in the polar transcription termination or the replication termination. So in this figure you can see this TTF1 binds with this hydroxide, terminate transcription one side and the replication from the another sides. By this prevention, it prevents the replication in transcription interaction during the RNA transcription. Similarly, there is a protein which is present in yeast, that is Web1, which also perform the same function as TTF1 perform here. So TTF1 interacts with CSV, F5, PCAF, helps in chromatin remodeling. Other than that, it interacts with the ARF, NTM2 and help in cell cycle regulation. There are also interactors which interact with the TTF1 and play a specific roles. So for the finding of this novel interaction and the novel function, we designed these two sets of the experiments. So for this set of experiment, from the previous studies and the discovery from Ingrid Bloom, she is the pioneer of this TTF1. So we found that the 190 amino acid of the N-terminal is inhibitory domain for the DNA binding of this TTF1, or it also inhibitory for the function of the TTF1. So that's why we truncated this 190 amino acid from this TTF1, codon optimized and prepared a construct that is delta 190 and TTF1. So after this construct preparation, we clone this into MRQ vector, then subclone into the PMOS C2X vector and express in the BA21 with this E3 ubiquitin ligase system, interact with DCAF, and by the interaction of these different specific proteins, it's play a significant role in different processes. So on the basis of that, and I earlier explained you and showed you that TTF1 also bind with this shows the interaction with CSP. So we hypothesized that somehow this TTF1 DDBR interacts and play a significant role in UV-mediated DNA damage repair. So further to check the interaction between DDBR and TTF1, we further perform this set of experiments. So next the set of experiment is, first we silence this TTF1 via siRNA in HEC293 cells and found that after the silencing of TTF1, the DDB1 protein also decreases in HEC293 cells. But interestingly, we found that when we silence the DDB1, the TTF1 interaction increases in these HEC293 cells. So this results concludes that the TTF1 is a target for the DDB1, but DDB1 is not a target of TTF1. And further, this result should be checked by the ubiquitination process, which we hypothesized is in line of this experiment. So after that, we also want to understand whether it shows any significant effect in UV-mediated mimic system. So what we did in this HEC293 cell mimic this 1 minute UV exposure. So first here you can, sorry for this hazy picture. In this figure you can see after 1 minute UV, you can see the gamma H2X increases. So it means after 1 minute UV exposure, this system shows the UV-mediated DNA damage. So similarly, I performed the same experiment for the TTF1 and found that after the 1 minute UV exposure, the TTF1 occupancy in cells increases. It shows that TTF1 has an important role in UV-mediated DNA damage. So this result hypothesized that this TTF1 important during the UV-mediated DNA damage repair. After these set of the experiments, I would like to conclude my talk. So first, we stated that DDB1 is a novel interactor of TTF1 and TTF1 is a target for DDB1, and the establishment of role of TTF1 in ANIA, that is nucleotide excision repair, which is UV-mediated DNA damage repair, will open a new aspects for the direction of the DNA damage repair pathway and also role in different diseases, which is called due to impairment of DNA damage repair. And here I would like to mention that TTF1 is already established in colorectal cancer and lung cancer upregulated. So this we basically focus on the mechanism of this interaction and the specific pathway. So after all this, we successfully can state that the TTF1 has a significant role in UV-mediated DNA damage repair. I would like to thank my PI Dr. Samrin Kumar Singh, my lab members, and my funding sources, that is DBT. Thank you so much.
Hello. Very nice presentation.
Thank you, sir.
Open for discussion.
Is there any mutation of this TTF1?
Sorry, sir.
Mutant form?
Yes, sir. My other lab mate is working on this mutation. Actually, there is already sufficient literature about this TTF1. They mutated the specific domains of this TTF1. Actually, I already so many research performed on this structure of TTF1, where we find that different domains. This TTF1 has a different domains, and these mutated domains have different type of functions. So it is already established.
And also it only replace UV-induced damage, or it will also repair?
Sir, we didn't check yet, so yeah, it may be said. This is a good question. Good question, sir. I will include this. Thank you so much.
Your study you are mentioning that DCF that is not interacting with TTF1.
Sorry, sir.
DCF-AF3.
Sorry, sir.
DCAF3, you are actually cloned the one you are actually mentioning about.
DCAF3.
PCNA.
PCNA.
Go ahead.
Yes, sir.
Yeah.
This DDB1, sir.
Okay. You mentioned about that is not interacting with TTF.
Sir, it is interacting. The whole presentation shows that the DDB1 and TTF1 are interacting with each other. That is the.
There is another molecule you are actually going and identifying. indica, yeah,
Sir,
DCF.
this is hypothesis because the E3-ubiquitin ligase system works with the help of this decaf. Decaf like a adapter protein for the other proteins. So maybe that TDF will interact with the decaf. Sir, we are in line to discover that.
Then that molecule have any interaction with UV or only DCF?
Sir, only sorry sir, I didn't get it.
That molecule have any interaction with UV or just TDF have
Sir,
interaction?
without UV. We established this without UV it interacts with the protein. Because when we perform the LCMS, we use the HEC93 cell acid which is not UV mediated or UV exposed cells.
Then what is the rationale you are actually using that DCF study purpose? It's not interacting with TDF. No, just want to know that DCAF3 you are actually identifying. And that is not interacting with TDAF for.
Sir, we haven't checked that decaf is interacting or not. We just checked only and we found that only that DDBL is interacting with decaf. Maybe it can interact, sir. Yes, sir, sure.
You said that you had made a deletion and you had
Yes, sir, 190
and
aminoacids.
you have made a synthetic construct. How did you make it?
Sir, we removed this 190 amino acids and codon optimized.
How did you do? Yeah.
Sir, the gene sequence which we when we sent for the synthesis of this codon
You did it
sequence.
yourself, codon optimization or it
Sir,
was
with the
done?
help, yes, sir, I did with the help of my PI, with the help of some bioinformatics. So, from this gene, we
So
deleted.
this original gene, why did you have to do a codon optimization?
Sir, codon optimization is important because it is a mammalian protein and we have to express in bacterial systems. That's why.
Normal protein was not getting expressed in bacteria?
Sir, we tried it. Actually, I also tried it, but we couldn't successful. So then we go for this codon optimization and the biopreparation. We also tried to, not me, the grid group also tried to purify the whole whole stretch of this gene, but she also couldn't successfully that because that the inhibitory domain which I am talking is basically a oligomerization domain and if
So this deletion of 190 amino acid,
yes sir.
so that has helped in expression.
Yes, sir, it is.
In what way?
Helping.
In what way has it helped in
Sir,
expression?
the purified protein is stable in solution. It is not aggregated in solution. And when we purify the whole stretch without deleting 190 amino acid, it aggregates in the solution. So it is very difficult to proceed further. Thank you, sir. Sir, I can also show some.
No.
Okay, thank you.
We are very short on time.